Okay, so in this report, pretty much a frown going upside down. We're going to turn two useless pieces of scrap plywood into a set of 4 wheel chocks that are going to last you for years, and you can use them for roadside repairs and general jacking duties around your own fat cave. And we're going to do some basic production engineering, which is kind of a skill set that you could apply to any DIY project, and it's going to slash the burden of measuring and marking everything out when that's really not called for in many ghetto engineered jobs, especially this one. Plus, it kind of boosts the repeatability of your machining operations. And finally, we're going to do it all off-grid using the mighty Bluetti AC200MAX lithium iron phosphate battery inverter portable power station. What a mouthful. Without once plugging anything into the mains. If the Bluetti does not power it, I am not going to use it for this project. So, with all that said, let us rip like it's London's East End in 1888. I'm John Cadogan from AutoExpert.com.au, and I get new cars cheap. In Australia. Sorry, overseas dude. Website. Card. Click it, dude. We stopped sending those individual carrier pigeons last month. One of the many COVID cutbacks. Bluetti supplied the AC200MAX for this assignment. It's the same one I've had here for months. I've already done a full review of that, so I'm not going to rabbit on too long about the specs. Basically, it provides 2,000 watts of pure sine wave 240 volt AC power, plus it has several different USB outputs, 12 volts DC out, and 2 inductive charge pads for Yo mobiles. Lithium iron phosphate chemistry makes it durable and robust. It's an excellent backup for our increasingly beat up, broke down electricity grid, with the prospect of power failures becoming ever more likely. The AC200MAX works for camping, boating, caravanning, working on site off the grid, such as what we're simulating today, and keeping the essentials at home fired up if the power does go down, like the refrigerator and the TV, a few lights kind of thing. I'll put a link to the review up, yeah, if I remember. Bluetti has a sale on right now until the 24th of July. Big discounts on the AC200MAX you see here, and the even more powerful AC300 plus its B300 modular battery system, which I will be reviewing next up. Link in the description to all of that. So, I ended up with these two really quite crappy pieces of 10mm plywood when I bought a benchtop 10-ton hydraulic press. The ply was the box, right? And I wanted to do something worthwhile with it because it's kind of a waste just to deep six things of this nature into landfill. It's certainly not furniture grade Baltic ply or something, right? So the second use options were limited to something a little more ghetto. And being the A-grade engineer that I am, instead of doing research, measurement, calculations, things of that nature, I diligently ripped off the design of a rubber chock that I already had lying around the fat cave. There is no need to reinvent the wheel, dude, or its friggin' chock. So I cut a template out of cardboard, which is, of course, the universal production prototyping material. Cardboard is just one of those things that separates us from the animals. And with that done, you just have to think about setting the job up to minimise the wastage and what tools you're going to use to turn the stock you've got into the work pieces you need. And you could cut all of this out by hand. That would not be too hard, but kind of boring. There's 5 edges per piece, and you need 40 pieces if the thickness is 10mm, so it'd get old. You could cut it with a jigsaw or a bandsaw. I've even got a job site table saw, so I was planning to use that. But hey, small problem. The table saw is 2,200 watts, and the AC200MAX will not run it. I tried, and it just kept tripping. But it will run my drop saw, which is a Bosch unit that's rated at 1,800 watts. It's just a chop saw, that saw, and yeah, a radial arm version would have made the job a hell of a lot easier, but hey, I've already set the goalposts here, and I've got to stay on the field to score, right? The first job here was to rip the stock into 150mm strips, which is about 6 inches in the old money. I spent 10 minutes with a few scraps of old pallet wood and some offcuts to make a jig that's essentially just a clampable rip fence set at 150mm cut width, okay? No need for measurement after that whatsoever. You just clamp the jig and repeat, right? You use as many additional clamps as you need to secure the work to the bench would be my advice as well. Then you have both hands free to use on the power tool, which is kind of important. The pro tip here, of course, if you've got both hands on your saw, it's actually very difficult to cut all of your fingers off. One-handed, not so much. And if you're a lefty like me, you've got that lifelong disability, right? Just learn to use a power saw right-handed. Circular saws in particular are extremely dangerous to use left-handed, and it's not that hard to adapt. The rule is adapt, improvise, and overcome, lefty dude. You've been doing this your whole life. I know I have. Anyway, you should also wear appropriate PPE for jobs of this nature. AS 1337 eye protection, not negotiable. Hearing protection too at times. You just got to take some personal responsibility for your own safety. If you are working inside, I would suggest get dust extraction and wear a mask. But this is not as critical outdoors, obviously. And I prefer to do wood projects outdoors, mainly because one's fat cave does not then fill up with cubic meters of sawdust. If you end up with a bunch of strips, all 150mm wide and all 10 fingers still attached, you got this first step mainly right. So congratulations, dude. That should inspire some confidence for the future. I started with the Bluetti fully charged for this project, and the ripping took me about 15 minutes. The 2,048 watt-hour battery in the Bluetti was sitting on 95% capacity remaining, with all of the rip cuts done and dusted. That's 10 strips, all about 500 long and 10mm thick. The saw is 184mm diameter and rated at 1,500 watts, which is 2 horsepower in the old money. And the Bluetti drives that easily. From a production engineering perspective, the most efficient way to do projects such as this is do the one operation, like all of the ripping, and then move to the next operation. Do the same operation on all of the parts and then rejig for the next step and do all of that. So the stock here has 2 reference surfaces, the long sides of each strip, and I can use those to get a 3rd reference surface, which would be the 10-ish degree rake on the back edge of each chock. I never bothered to measure that angle, but when I matched the angle of the template to the drop saw, the protractor on the saw read 8.5 degrees. And ultimately I got 4 blanks out of each strip, so I'm going to cut those 8.5 degree angles on each end of each strip first, and I'm going to use those angled edges to jig up to lop each strip in half with another 8.5 degree splay, with no measurement after the setup. 10 strips of ply times 4 blanks per strip equals 40 blanks, each 10 thick. That's enough for 4 chocks, 100mm wide, so the 15 minutes that I did spend hunting for additional plywood just in case I needed it, which I'm not actually going to need, then yeah, dude, that's a quarter hour of my life, which I'm never getting back. The drop saw is 1,800 watts, and it has a 254mm blade, which is 10 inches in the old money. It takes a lot of electrical grunt to whip that blade straight up to 4,500 RPM too, like a big surge briefly. You can hear it. But the Bluetti is rated for 4,800 watts on surge, so it's no problem to run this tool seemingly all day long. For the middle cut, I screwed the drop saw down into the bench to fix it in place temporarily, and I clamped a big chunk of off-cut angle iron in place as a kind of ghetto end stop, one that conveniently never fills up with sawdust. And after that, it's really just a matter of improvising additional stops with clamps or scraps, like whatever you've got on hand, to make subsequent cuts repeatably. You're aiming for a chock that's about 150 high and a 45-degree face that engages with the tyre tread. Everything else about wheel chocks is really just aesthetics. If I'd had a radial arm drop saw, I could have cut the 45s in the one hit, but because I didn't for this project, because of the power constraint that I subjected myself to, I jigged up to flip the workpieces and I cut the 45s in 2 steps. Then I just knocked the corners off repeatedly, and all up, this was rather a lot of drop saw cuts and a lot of hard starts back to back for the motor. And it all seamlessly functioned with Bluetti powering it up. With all 40 blanks finally roughed out to size, the battery level was 79% remaining. A judicious sand with 120 grit to knock off any rough edges and high spots drank a further 2% of remaining battery capacity, and then it was time for gluing up. The plan here, 10 laminations per chock, means 9 glued joints per wheel chock, and I'm just using standard PVA wood glue, the cross-linked stuff. The glue is stronger than the wood, and it's loaded in shear in these joints, which is ideal for adhesive joints, so no additional fixation is going to be required to make these things durable. But you do need to hold it all in place prior to clamping, and the glued joints are really slippery when they are wet. So the laminations are quite prone to sliding all over the place, which is why I'm securing them in place with 20mm brads and shooting them in with a pneumatic brad nailer. Compressing air is hard work, so this is another opportunity to drive the AC200MAX right up to its limit. The compressor is a brand new Renegade Industries 2 horsepower unit, which is about 1500 watts. Single cylinder, direct drive, and I'd suggest that Renegade makes some pretty good stuff. A crowd called Trade Tools in Queensland imports them. I've got quite a collection of Renegade stuff now, and it's pretty impressive kit for a home shop, right? I don't have a relationship with Trade Tools or Renegade beyond being just a fairly satisfied customer. Anyway, I bought the compressor specifically for this assignment as a realistic example of what you might take off-grid, and it is highly portable, so it's ute and van friendly, and you won't need a crane to lift it on and off at each end. I plugged it into the Bluetti, I fired it up, and I filled the 12-litre tank to 125 psi, and it all went like friggin' clockwork. And the cut-off switch kicked in, deafening silence, like it was textbook, dude. So I started gluing and nailing. And then 3 or 4 laminations into this process, in the immortal words of Jim Lovell, or maybe it was Jack Swigert on April the 14th, 1970, Houston, we had a main bus be undervolt, or in this case, an inverter undervolt alarm. At this point, we've really got to talk about the elephant in the room of this project, which would be the compressor. Because I had a few problems with the compressor, despite testing the friggin' thing with the AC200MAX in the lead up to contriving this whole project. And I decided on the basis of the testing I did that the compressor was in because the AC200MAX would drive it just fine. I got the compressor out of the box. It's 2 horsepower, which is 1500 watts roughly, and the AC200MAX is good for 2000 watts and 4800 on surge, right? So I've gone, yeah, should cope, let's test it. So the test that I did was I ran the compressor in, and dude, if you buy a compressor, you really should run it in because that allows the rings to seat properly and it's going to last longer if you do that. So the procedure is you undo the bung that lets the pressure out of the tank and stops it pumping itself up if you leave it out, and then you just run the motor and the compressor for like 20 minutes. And that seats everything in, gets it nice and warm, blah, blah, blah. it's run in. And the AC200MAX did that just fine. And it's like pumping out 1400 watts the whole time, okay? Then I screw the bung up, and then it starts to pressurize the tank, and the pressure comes up to 125 psi. The switch tells the motor to shut off. It shuts off, and I go, good enough, dude, compressor's in. So then we're doing the project. I get all of these blanks cut out, and I'm starting to laminate them up. I got the glue out, and I got the brad nailer connected, and the tank's pumped up, and it's all looking pretty good. Right up to the point where the pressure comes back to 90, which is roughly where another pressure switch tells the motor to turn itself on to re-energize the compressor and pump the tank back up to 125. That's that on-off cycling that essentially all compressors do. And the AC200MAX doesn't cope with that because the head and all of that sort of delivery side of the compressor is energized at 90 psi. So the motor's got to work against the load of 90 psi to get itself started. And it's just over the line for the AC200MAX. It trips out and it won't run the compressor. It took me a while to figure that all out, and I'm sort of scratching my head going, where did I go wrong? So as part of my investigation into that, I whip out the Bluetti's big brother, the AC200MAX's big brother, which is called an AC300, and it comes with a B300 battery, or it's designed to work together. So you've got one box that's the inverter and all the inputs and outputs, and then you've got the battery, and you connect it with a cable, and it just runs, okay? So it's 3 kilowatt hours and 3 kilowatts on the inverter, and it runs the compressor no problem. And I'm going to do a test of that. That's coming up, okay? But I'm stuck in this world where I've contrived this project and I can't use anything that the Bluetti won't run. So I got to come up with a hack for the compressor that will allow the Bluetti to run it. And this is like the smallest compressor I've got. So what I did was I regulated down to about 50 psi, and I turned the switch off so the Bluetti wasn't continuously trying to turn the compressor on. And then I just kept using the brad nailer until I got to about 45 or 50, and then it wouldn't hammer the brads in appropriately, right? So at that point, what I did was I undid the bung and I let all of the pressure out so the tank was empty. And then I pumped back up from empty with the AC200MAX, which it copes with just fine. It starts out at like high 1400s in the watts, and it cuts off at 125 psi at sort of high 1500s in the watts, right? And that worked just fine. And I did that for 9 iterations of that convoluted process, which is watch the pressure gauge when you get down to 50, turn the unit off, and then, you know, empty the bung, dump all the air out, and then go again with the Bluetti, okay? And if that's a cheat, then okay, fair enough. But if I was out in the boonies working on some shed and I had to do whatever with a compressor, then that is the only way I'd be able to do that. And as I see it, that's still in the wheelhouse of fair game for this project. The other thing I need to tell you, I guess, is that if you're ever stuck in that situation, there is often a workaround, and if you just get a little bit solution-oriented, you can often just tweak the system one way or the other and come up with a fix that's not ideal, certainly, because that is a lot of juggling. You know, when the pressure comes up in the tank, you turn the switch off, and then you run the tank down to 50, and then you empty the air out, then you turn the switch back on, and then you use the Bluetti to pump it up. Like, it's not ideal, but it works. And if you need a compressor and you are, quote unquote, pardon the pun, under pressure, then that's how you do it, okay? The other thing I'd suggest is, and it's probably staring you in the face for the first time during this video, the carrot tops on the finished product, right? 2 reasons for that. Number one, this way up, dude, because that way up, definitely not as good. Designed to go this way up, and I could have made them symmetrical, I suppose, but anyway, I didn't, and it's a this way up deal. And also, obviously, the fluoro makes it much harder to leave the chocks behind in the boonies if you're packing up in a hurry to get back on schedule after having a flat tire. So Two reasons for that, and you know what? I could have done a better job with all of that, masking it off and that sort of stuff, but I see these as being way too perfect already. At the end of the day, they're friggin' wheel chocks. I have to stress at this stage that this alarm is not an example of the Bluetti being defective. It was merely telling me that I was attempting to whip it just ever so slightly too hard by asking it to crank the compressor against that 90 psi internal back pressure. This is pretty much the second time I've found the limit of the AC200MAX's off-grid workshop capability, right? It'll just drive the compressor with the hacks as discussed, the same as it will just drive my Lincoln Electric MIG welder if it's loaded with 035 flux cord wire. Having used it a lot now, I'd say that for general carpentry and metal fabrication tools like most saws and drills and angle grinders, drill presses, and I've used it to drive a mag drill, the AC200MAX is ideal for these kinds of things, but for really grunty machines, especially ones that need to crank from stopped under load or have to deal with a great deal of initial inertial resistance, it might not be ideal. And if you want it to do something of that nature, you would want to test it exactly as you intend to use it before going out into the field and just, hoping for the best. Next day, the clamps came off and I tidied up the rough chocks. I cleaned and tweaked the shortcuts on the drop saw and I hand planed the long sides. And I gave everything a final sand, which started out at 40 grit to beat any high spots into submission and 120 for a final finish. They're certainly not perfect, but then we're not making furniture for Buckingham Palace here, are we? I sealed them with some more PVA, this time Bondcrete in a can, and the ply just sucks that up. It fills the voids, it dries fast and hard, and it's waterproof. Then I did the roughest masking job on earth, yes, and carrot topped them with some spray enamel, as just discussed. I didn't film all of that, the painting and the carrot topping, because it would literally be a documentary of watching paint dry, and there are some lines that even I won't cross. I'm actually pretty happy with how they turned out, and there was almost no waste. And this is mainly because I had a big think about it before I cut anything. Thinking first and cutting second is a process which I note many DIYers get arse about, sometimes with very expensive consequences. Anyway, at the end of this process, including vacuuming up the plane shavings inside the fat cave, there was still an indicated 51% remaining capacity on the AC200MAX. In other words, I had used about 50 cents worth of electricity at peak rates, and I'd had a pleasant afternoon outside the fat cave in the fresh air, composing yet another fine symphony in power tool flat. Yes, living the dream. And this is achievable during a power failure, potentially. Let's not forget, the Bluetti's 50-odd% remaining power would certainly be enough subsequently to crank a refrigerator through a couple of cooling cycles overnight, run a few LED lights, recharge a laptop, keep the mobiles juiced up, and then you could keep in touch with the outside world. You could power up the TV, etc., if the grid is down. If the sun is shining during your DIY marathon, then you could conceivably lay out a couple of Bluetti solar panels and recharge the unit while you are working. The AC200MAX is compatible with being simultaneously charged and discharged. These two panels here are called SP350s. They develop 350 watts maximum apiece, for a total of 700 if you've got two. So if you can get 3 hours of full super bright summer sunlight, that is a complete sun-powered recharge for your AC200MAX. The AC200MAX has an onboard solar charge controller as well, so all you need to do is plug the panels in without stressing too hard over the technicalities, and you will not blow anything up. Right now in Sydney, however, it's just 4 weeks after the winter solstice, so the sun was pretty much at its lowest elevation and intensity, and there was a lot of wispy high-level haze in the air betwixt it and me on the day in question. Even so, the solar cells managed to deliver consistently over 200 watts, which would see the AC200MAX in its 50% depleted state fully charged in 5 hours. And just for complete clarity on this, the panels were not in play while I was making the CHOCKS. I deployed them and tried out the panels the next day. 2 kilowatt hours, which is the total capacity of the AC200MAX, it's a pretty impressive start to an otherwise bleak evening if the power is down. Like, you would be the envy of your neighbours. So, all up, this was a productive afternoon, plus not having to live the Neanderthal life later on during a potential power failure. And it's not just about power failures, right? You might be building a shed way out in the boonies. This project is an example of the kind of thing you can achieve off-grid if you have work to do and there's no on-site 240-volt supply. There's no generator screaming in your ear while you're trying to think, so that's a plus. And it's certainly not going to annoy the neighbours at 10 p.m. It probably took about, 3 or 4 hours to make the 4 wheel chocks from scratch, if you don't count the filming, which friggin' takes forever. And if you've wondered why I even bothered to do this, when you can just go and buy a pair of perfectly serviceable Chinesium wheel chocks for 20 or 30 bucks on Amazon, it's just satisfying to make stuff. And it gives the people you live with a well-deserved break from you. They really deserve that, dude. It's good for their mental health and also yours, incidentally, kind of thing. The only problem I have with this DIY stuff, right? Everything you make in this way is a prototype. So if you had to make another 4 wheel chocks, they would be twice as good and you would get it done in half the time. And I guess the other thing that can happen with these processes is that your inner perfectionist can overtake you if you're not really careful. And the quest for perfection is the enemy of making anything good enough for the engineering ghetto. So I have to keep telling myself that they're wheel chocks, dude, not fine furniture. If they stop the car from rolling when you are jacking it up, good enough, well done. These are certainly better than they have to be from a ghetto engineering perspective. Remember to check the description for links to Bluetti and some other useful upgrades to your own fat cave. Now, I know this has been an endurance event, but I hope this project has, at least in some small way, inspired you to, go forth and not cut off any of your own fingers. It's always a good day in the fat cave if it does not end with a discussion about microsurgery.